A very good morning, my dear students. Last session, we have started circular motion, isn't it? In this circular motion, a maximum topics we have done it. Maximum topics. But still, continuation and recap we are doing it today. Because I have seen some students message me personally, there was some echo in the last class. I hope that problem you'll not be having it in today's class. So that is why let us do a quick recap, then we'll continue the circular motion topic. All right. What we had discussed earlier, we started with the concept of circular motion. In this circular motion, we have considered a circle where a particle is moving from the point A and reaching to the point A dash. See here, from A to A dash. Here, this is the midpoint. See the radius of the circle, and this is also the radius of the circle. So what I can say here, that this is the radius vector from the midpoint to the position of the particle. From the midpoint to the position of the particle, this is also the radius vector r bar. So this is also the radius vector r bar. And there is an angle theta here. So this theta is called angular displacement. Will you agree with this, my dear students? So this is called angular displacement. What is this? Angular displacement. All right. Where r bar is a radius vector. The last class I had told you clearly, this angular displacement is also called as a plane angle. What is that? Plane angle, which is equal to length of the arc, A dash. This is the length of the arc, A to A dash, right? So particle is moving in this way. So this is length of the arc by radius. So this is plane angle. And this angular displacement will have SI unit called radians. What is that? Radian. So imagine if the particle is finished one complete revolution. See, imagine a particle is finished one complete revolution. So then I can say here 2 pi radians it is finished. Will you agree with this? All right. Imagine if a particle is finished, how much this theta will be? 2 pi radians. And you know this 2 pi radians is equal to 360 degrees. How much is the theta? 360 degrees. So from here I can also write theta is 360 degrees, right? So you can see, right? 2 pi. So this is radians and this is in terms of degrees. So this I can write it as 2 pi radians, 2 pi into 1 radian, which is equal to 360 into 1 degree. Okay, so this I can write in this way also. So from here I can write the formula for 1 radian, which is equal to 360 degrees by 2 into pi. Okay, so this is in terms of radians. Now, for example, if there are n revolutions I've considered. So then I can say your theta is equal to 2 pi into n radians, in terms of radians only. Okay, 2 pi to here, theta is equal to 2 pi radians into 1. Okay, because it is one complete revolution. So this is angular displacement. Next, what we have discussed is angular velocity, my dear students. What is that? Angular velocity, which is denoted with the symbol omega. Here, omega average is equal to delta theta by delta t. That is change in angular displacement by change in time. So if you want to write the instantaneous value, so this will be a d theta by dt. I have told you already, this theta value will be in terms of time. This theta is depending on time. Imagine the theta is t square plus 1. Then you can find the instantaneous angular velocity at a particular time. Let's take t is equal to 2 seconds. Substitute here. So instantaneous angular velocity is a d by d theta of t square plus 1. This I can write d by d theta of, sorry, d by dt of t square plus 1. So what I can write, d by dt of t square is 2t plus d by dt of 1 is 0. So this I can write t into, at what time we are finding instantaneous velocity, angular velocity, 2 seconds, 2, 2. It is 4. Okay. So SI unit, you can say the numerator having SI unit is radian, denominator is having SI unit is second. So SI unit of angular velocity is radian per second. So the same thing, so radian per second. Remember the values here. Instantaneous angular velocity is d theta by dt. Average angular velocity is delta theta by dt. Here itself, one more I would like to inform, the one more important point here, which is this omega is equal to delta theta. For one revolution, I'm talking here itself. So for one revolution, the delta theta will be 2 pi radians. Okay, by, for one revolution, time taken by the particle to complete one revolution is the time period. What is that? Time period. So this is t seconds. So what is your omega? Omega can also be written as 2 pi by t radian per second, my dear students, right? So this can also be written as, in the lower classes you might have learned, 2 pi into 1 by time period is the frequency. Omega can also be written as 2 pi into frequency, and many of the questions will be using this. Omega is equal to 2 pi by t. This is what the concept we have learned so far, okay, in the circular motion. And one more point here. In this circular motion, at any instant you take, the particle is will have two accelerations. One is tangential acceleration, another one is centripetal acceleration. Okay, at any point you take. So if you want to find the velocity of the particle at any point, you need to draw the tangent. If the velocity is increasing, tangential acceleration also in the same direction. Remember, once again, these are the things we have discussed in the last class. Just because some of the students informed there is a disturbance in the video, I'm making this video once again, so in the form of a quick recap. Okay, so at any point, instantaneous velocity is increasing in the uniform, in the circular motion, not the uniform and non-uniform. I have not started. Okay, in the circular motion, if the velocity is increasing, tangential acceleration will be in the same direction. Okay, but the centripetal acceleration will be always towards the center. Centripetal acceleration is equal to v square by r. This is from the lower classes you might have learned. Okay, centripetal acceleration is v square by r. Now, tangential acceleration, that is the most important thing. Okay, so this tangential acceleration is at. This value will be equal to dv by dt. So what is this velocity here? This is the velocity called linear velocity here. At any instant, if you find this velocity, so at this instant, if you want to find the velocity, that is called the linear velocity. So the resultant acceleration at any instant you can take when a particle is moving in a circular motion, ac square and at square, square root ac square plus at square. This is the resultant acceleration. Okay. All right. Now let's look at the next topic. Here itself, we have discussed angular acceleration. Angular velocity is done, angular acceleration. Simple. Angular acceleration also will have two. Average angular acceleration, which is equal to delta omega by delta t. So where SI units will be radian per second square. Okay, so where SI unit is radian per second square. So instantaneous angular acceleration will be d omega by dt. Here also this omega is the function of time minus distance. Okay. Now look at the things whatever we have learned so far. From there I can say the relation between linear velocity and angular velocity, which we have derived v is equal to r omega. V is equal to r omega. Look at here, v is equal to r omega. What is v? Linear velocity. What is omega? Angular velocity. What is r? R is the radius of the circular path. What is that? R is the radius of the circular. Clear? Now, here comes the point called circular motion, right? So this circular motion can be divided into two parts. One is uniform circular motion. The another one is non-uniform circular motion. In uniform circular motion, speed is constant. What is that? Speed is constant. Let me draw two diagrams for your better understanding. Look at here. This is the radius of the circular path. Imagine here we are discussing uniform circular motion. Here we are discussing non-uniform circular motion. Simple things. So this is the radius r. So at any instant you take, the particle will be moving with the same speed. Speed, I'm not talking about velocity, my dear students. So at any point you consider, the particle is moving with the same speed. All right. So here, speed means what? The magnitude of the velocity. Will you agree with this? So magnitude of the velocity is called the speed. At any instant, speed is same. I said velocity will be velocity will be changes because velocity is a vector quantity. Yes or no? It will have direction. You can see here. At this instant, velocity is upward direction. At this instant, velocity is the west side, here downwards and here east side. Okay, so the direction of velocity is keep on changing. In uniform circular motion, velocity will change and the speed remains constant. From here, I have told you clearly in the last class, all the scalar quantities will remain same because they don't have direction. All the vector quantities will, all the scalar quantities will remain same as they don't have direction. All the vector quantities will be keep on changes, right? All these vector quantities will keep on changes because they have direction, right? Here, here, carefully see. As the magnitude of this velocity is constant, okay? So there is a centripetal acceleration towards the center. Any particle is moving in a circular motion that may be uniform or non-uniform. Centripetal acceleration will be acting in this way, and tangential acceleration is like this. So here, centripetal acceleration is v square by r at this instant. With what speed it is moving? That's v. Okay, speed, I'm talking about speed. Whatever it may be, the speed is constant, right? At any instant. That may be here, maybe here, or maybe here, right? So tangent, if you draw, that is speed. So tangential acceleration, what I've told you, my dear students, dv by dt. Okay, we need a value of acceleration. Direction is mentioned here. At this tangential acceleration is like at this tangential acceleration, at this tangential acceleration will be like this. Okay, so the speed we need to consider here because direction is already known to us. So here d by dt of mod v bar. Mod v bar is the magnitude of the velocity. Magnitude of the velocity is the speed in this case. So that speed is constant. So I can say d by dt of a constant is 0. So in uniform circular motion, there is only acceleration present, which is equal to centripetal acceleration, my dear students. This is the uniform circular motion. All right. This is the uniform circular motion. In non-uniform circular motion, here comes an important point. In non-uniform circular motion, this is the radius r. Here, at any instant you take, the particle will be moving with the different speeds at any instant. Particle is moving with the different speeds. Okay, see here v1, v2, v3, v4. So imagine the particle is increasing its speed or velocity. Here speed is changing, velocity is changing, all the quantities will change irrespective of the scalar and vector. All the quantities will change here. Here also centripetal acceleration is must because any particle to move in a circular path, centripetal acceleration or centripetal force which is directed towards the center is most important. And here, as the velocity is increasing, tangential acceleration will be in the direction of velocity. Okay, so tangential acceleration is a d by dt of v. So here comes an important point. D by dt of v is equal to r omega because this is the linear velocity, but the particle is moving in a circular path. Here you should use the relation between v is equal to r omega. From here what I can write, r is constant, d by dt of omega. Okay, so r into d by dt of omega is alpha. So tangential acceleration is r. At any point you see, my dear students, here, so centripetal acceleration and tangential acceleration are perpendicular to each other. Here also you see this is the centripetal acceleration, this is the tangential acceleration, they are perpendicular to each other. So then the resultant acceleration I can say, which is square root ac square plus at square. So this I can also write it square root AC square is how much? V square by R whole square plus AT square. This is R alpha whole square. Okay, clear? Sure. Now, here we have centripetal acceleration is V square by R. So this v square, it is r omega whole square by r. So this is r square omega square by r. See here, r cancelled. So centripetal acceleration, I can say it is r omega square. So this I can also write it as r into omega is what? 2 pi into frequency, right? So this centripetal acceleration I can say r into 4 pi square f square. Okay, so this is the centripetal acceleration in terms of omega. This is the centripetal acceleration in terms of frequency. Okay, so remember these two. Now let me draw three important diagrams here. Only three important diagrams. One, two, three. Okay. So this is the point you already know. Imagine it is a center. Centripetal acceleration is here. Tangential acceleration is here. When the speed is increases. Okay. So this is 90 degrees. The resultant acceleration will be like this. Yes or no? This is resultant acceleration. Same situation when the speed decreases, let us see. This is the centripetal acceleration. The particle is moving like this. Speed is decreasing. Then the tangential acceleration will be like this. This is the tangential acceleration. Velocity is decreasing, right? So this is the tangential acceleration. Here also the acceleration, centripetal acceleration and tangential acceleration, you see, both are perpendicular to each other. So here the resultant acceleration will be like this. So this is the uniform circular motion. This is the centripetal acceleration. Tangential acceleration is 0 in uniform circular motion, where velocity is constant. Okay, here velocity is increasing, tangential acceleration will be in the direction of velocity. Velocity is decreasing, but the particle, in all the cases, the particle is moving in this way only. Okay, let's say this is anti-clockwise direction. Here, when velocity is constant, acceleration is 0. Tangential acceleration is 0. So here the only acceleration present is acceleration which is centripetal acceleration. So your net acceleration also will be in the same direction. Remember these three things. Okay, fine. All right, and let us discuss a simple example question. How the question was asked in the previous NEET exam from the same concept of acceleration. How the question asked, let us discuss. So this is the question asked in NEET 2016, my dear students. There is a figure given where acceleration is given as 15 meter per second square, which is represents the total acceleration. They have clearly mentioned the total acceleration of the particle is given. This is the particle is moving in a clockwise direction, right? The particle is moving in a clockwise direction in a circle of radius 2.5 meters. So the question is, what is the speed of the particle? What is the speed of the particle? Understand? So they have given the diagram. No confusion. Simple. The simple diagram they have mentioned. Here, a very important thing. This is the center if you consider. They have mentioned it like this. there is a particle is moving in the clockwise direction. So clockwise direction in the sense in this way it is moving. This is the center and this is the radius r. They have clearly mentioned that this is the acceleration. This is the acceleration minus net acceleration. So this angle given as 30 degrees. All right. Now, how to solve this question? That's important thing. How to solve this? What is this net acceleration given? 15 meter per second square. Net acceleration. But the question is what is the speed of the particle? This net acceleration is due to both centripetal and tangential. Will you agree with this? So let us resolve this in terms of centripetal and tangential. This is centripetal, this is tangential. Tangential will be in the direction of tangent and centripetal will be towards the center. Right? See, when this is 30 degrees, this component, the component of this A is AC. This AC is making 30 degrees. So I can say from the vector resolution, AC is equal to A into cos 30 degrees. Okay. So centripetal acceleration is V square by R, which is equal to EA into cos 30. Cos 30 is root 3 by 2. Everything you have except your V. So V square is equal to R into A into root 3 by 2. What is R value? It's 2.5 into acceleration is 15 into root 3 by 2. Okay, so if you solve, you get the answer. V is equal to something, right? That V, you tell me now, that is your classwork. This is not clockwise, okay? This is classwork and do it now and tell me. This is the previous NEET exam question. Like this, the questions will be asked. Let us solve one more question for your better understanding. One more question. In the last class, I have given a simple question where most of the students have done mistake, right? So the simple question I'm writing here, the distance of a particle, look at here, simple question. The distance of a particle moving on a circle of radius 12 meter is measured from a fixed point on the circle and measured along the circle is given by S is equal to 2t cube meter. Question is, find the ratio of tangential acceleration to centripetal acceleration at t is equal to 2 seconds. Right? So what is our aim? Aim to find tangential acceleration to centripetal acceleration. Okay. Now, the distance of a particle is moving on a circle of radius 12 meters. So what is given here? So the radius is equal to 12 meters. Is measured from a fixed point on the circle and measured along the circle is given by S is equal to 2t cube. So S is the function depending on the time. From here you can find the velocity, my dear students. Velocity is equal to the ds by dt. S is what? Displacement here. So this I can write the d by dt of 2t cube. This I can also write 2 into the d by dt of t cube. So what I can say, 2 into d by dt of t cube, that is 3t square. Okay, 3t square. Now this is velocity. Keep it here. Now find the ratio of acceleration, tangential acceleration to centripetal acceleration. Okay, let's concentrate on tangential acceleration. Tangential acceleration is d by dt of v. Will you agree with this? This is tangential velocity. That's called linear velocity. So d by dt of v. So here v is a function of time. So v is how much? So 3 2s are 60 square. Understand? 60 square. So what I can write, 6 into d by dt of t square. Okay, for your better understanding, individually, simply I'm writing d by dt of t square. So which is 2t. So I can say it is 12t. At what time they are finding the acceleration, tangential acceleration and centripetal acceleration? At time t is equal to 2 seconds. Okay, so that is 12 into 2, which I can say 24 meter per second square. Okay, so this is the tangential acceleration at t is equal to 2 seconds we found, and centripetal acceleration is equal to v square by r, my dear students. What is v square? So v is directly given. Okay, so this is 60 square by r. R is how much? 12 meter. Okay, so this 6 into t square. T is at 2 seconds. So this value also at 2 seconds they are asking us to find. So 2 into 2, it is 4 by 12. No, it is 6, right? V is 6. Mm, just V square. 6 into t square. This is velocity. Just a so here, okay, understood. Here we missed one students. V square. What is V square here? V is 60 square. Okay, 60 square whole square. Okay, divided by R. R is how much given? 12. So this I can write 6 into 6 into t to the power 4 by 12. So this is 2 r. This is 2 3s are 3 into 2 to the power 4. Total how much? 60, which is 48 meter per second square. All right. So now the required answer is the ratio a suffix t by a suffix c. A suffix t is how much? 24 by a suffix c is how much? 48. So this answer is 1 by 2. Like these questions were asked, will be asked, my dear students. Alright, let's have a look at one more question. Simple questions will be like this. They'll give the diameter which is equal to 3 meters. They'll give you the linear velocity which is equal to 18 meters per second. They'll ask you to find omega, angular velocity. How can you find this? We know V is equal to R omega. V is given as 18, which is equal to R. This is the diameter. R is half of the diameter. It's 1.5 into omega. From here you can find omega. Find the omega and tell me your answer right now. Then another example question. Direct questions I'm telling you how they'll ask. There is a car moving with a speed 30 meters per second on the circular path whose radius is given as 500 meters. If the speed is increasing, see here, if the speed is increasing at a rate of 2 meter per second square. See, speed is increasing at the rate of increasing in the speed is called acceleration. So this is the tangential acceleration they gave me. Speed is increasing at the rate of 2 meter per second square. This is not a uniform circular motion. In uniform circular motion, speed is constant. Okay. But here speed is changing. That means this is a non-uniform acceleration which will have tangential acceleration. Question is find the net acceleration, my dear students. And net acceleration is equal to square root at square plus ac square. Right? At already given. AC you get it by using v square by r. V square is given, r is given. So then finally substitute the things here to tell me the answer now. Okay, clear? Let's check for one more, which is the last question for today's session. Right, last question. Let's have a look at it. The speed of the motor. This is also commonly asked questions. The speed of the motor increases from 1200 rotations per minute to 1800 rotations per minute in 20 seconds. Okay. Now, how many revolutions does it make in this period of time? In this period of time. Okay. Let's look at it. Simple way of solving this. The speed of the motor increases from 1200 rotations per minute. Rotations per minute. We don't have any quantity. Rotations per minute. We don't have any quantity related to rotations. We have radians, radian per second square. We don't have rotations per minute. In 20 seconds. Okay. So they're given delta t or t, which is 20 seconds. How many revolutions does it make in period of time? How many revolutions? So let us take n is the number of revolutions. Related to this n, we have theta is equal to 2 pi into n radians. Will you agree with this? So this n, I've told you, for n revolutions, the angular displacement will be 2 pi into n. Okay. Here we have the equations of motion in circular motion. Last class we discussed, where theta is equal to omega I into t plus half alpha t square. This is S is equal to ut plus half at square form. Here theta is equal to 2 pi n. Alright. Omega I. What is omega I? See, omega I can write it as 2 pi, right, by t for one revolution. For n number of revolution, let's take in this case number of revolutions are 10. T is the time period. So from here, what I can write, omega I is equal to, carefully say, 2 pi into, in first case, how much? So the speed of the motor increases from 1200 rotations per minute. So this is 1200 rotations or revolutions per minute. Time is 60 seconds. So from here, 0, 0 cancel, and this is 620. Okay, so this is 20 into 2 pi. What is that? Radians per second. Okay, so because omega, radians per second. So from the same formula, final value omega f is how much? 2 pi into small n. How many revolutions now finally? 1800. 1800 divided by 60. So here also 0, 0 cancel, and this is 630. So 30 into 2 pi radians per second, my dear students, radians per second. Okay. Now omega I, omega f is finished, and we have delta t also. So omega I you know, and t you know, t is 20 seconds. Okay, this is t 20 seconds, and this is alpha. Alpha is what? This t is also we know. Alpha is what? Angular acceleration. Here this is not instantaneous value. You can see the change in this angular velocity. 20 into 2 pi, 30 into 2 pi. It's not a less time even. See, when delta t tends to be 0, then only we will be considering instantaneous angular acceleration. But here delta t is not tending to 0. It is having such a big value called 20 seconds. So alpha is equal to delta omega by delta t. So alpha is equal to delta omega. What is delta omega here? Change of omega f minus omega I by delta t. So what is omega f? Omega f is 30 into 2 pi minus omega I is 20 into 2 pi divided by 20 seconds. So your alpha is equal to 2 pi if you take common, 30 minus 20 is 10 by 20. So 0, 0 cancel, right? So 1 by 2 into 2 pi radians per second square, because it is angular acceleration. Okay, now substitute in this formula all the things you substitute here. Theta 2 pi into n, which is equal to omega I 20 into 2 pi into t. T is 20. Okay, see here, t is 20 seconds, plus half into alpha. What is alpha? Here, just now we found 1 by 2 into 2 pi. It's pi. T square. T square is 20 square. So 20 into 20. Right? So this is 2 tenths. So 2 pi into n, which is equal to here how much? 400 into 2 pi plus this is 200 into pi. So that is also right, can be written as 100 into 2 pi. So here 2 pi, if you take a common, 2 pi into 500. Here 2 pi into n. 2 pi cancel. Carefully see. What is that n? N is equal to 500. So how many revolutions does it make in this period of time? It's 500, my dear students. 500 revolutions. All right. Clear? All the very best for your assignment. A lot of numericals we have done on these, so there's no other model than these models. Okay, good luck. Next class we will be revising complete projectile motion. Let me write here. Just keep this in your mind. Complete projectile motion and circular motion numericals we will be discussing. So what you have to do is just practice the formula. Just practice the formula, and your assignment also will be based on same complete projectile motion and circular motion. Practice the formula and come to the next class.